Hello everyone, thank you for coming. It's exactly 9 o'clock a.m. Pacific time. Thank you again for attending. We can begin with our session. Today it's going to be a very interesting one. For that I guarantee. It's titled Capturing 3D Reality Data by Flying a Camera on a UAV, and it's going to be presented by Dominique, our Senior Marketing Director. I want to welcome Dominique. For any questions you may ask in the questions tab, and we'll make sure to answer them during this live session, so feel to ask anything. Also continue to write us on recap.community@autodesk.com. Any feedback, comments, we'll really appreciate it. Also, if you haven't tried our products, go to our product page on autodesk.com/product/recap, and you can try our desktop version Recap for handling huge point clouds, and our web service, the Recap 360 service that we're gonna showcase today more. You may follow us on Google Plus page. You can visit many videos and sample videos, tutorials on our YouTube channel. And for all the latest news and technology previews, you can follow us on our blog on autodesk.com/blogs. There are many news there that we post regularly. So I'll give my place now to Dominique. Dominique, welcome.
Hi. Yes, hi. Thank you, Mitko. Hello, everybody. I'm Dominique Poliquin, French, based in San Francisco, part of the Reality Solutions Group of Autodesk, dealing with, as you know, laser scanning, photogrammetry, on any way to capture real life and turn that into reality data. So this topic today is about photogrammetry specifically, so taking a series of photos, turning this set of photos into a 3D model, on using a UAV or drone to take those photos and to create interesting content. So before jumping into the drone aspect of it, let me start by the basics of the photo to 3D process. I assume that all of you have ever tried either 123D Catch or Recap Photo or any other photogrammetry solution. It's always the same kind of operation. So you start by shooting pictures, a set of overlapping pictures around a scene or object, and then either you upload those pictures to the cloud, and then you create a 3D model on the cloud. There are other photogrammetry solutions which are desktop-based as well. And then you create automatically a 3D model from this set of photos. So to go a little deeper in this, how does it work? The basics of photo to 3D or photogrammetry is really about taking pictures, adjacent photos that will show a consistent content from which we will automatically identify and match features. So we would say, for example, if you take the example of these two photos on top here, I would say that this corner of the window is the same as this corner of the window on the other picture. So we will find and match about hundreds of corresponding points, so 2D points in adjacent photos, and then the magic happens. Then from these matching features in 2D space, we will be able to compute where each camera is located in space. So for each of the photo, we'll be able to compute the exact location, orientation, focal length, and distortion. And then once we have got the 3D camera for each of the photo, we'll then be able to triangulate more and create a shape, and then extract the texture mapping to create a photo texture 3D model. So having said that, looks simple, but it took us 25 years to get to this automatic engine now. And but there are a few rules that you need to understand. In order to get a good 3D model, you have to take the right photos, okay? No magic can happen if you don't have a consistent set of information in the adjacent photos. So you need to have one picture. We really recommend one picture every 5 to 10 degrees. So basically, if you move around an object like 360 around an object, being a house, being a small object, whatever, please shoot at least 50 to 60 photos for one set of photos, okay, if you want to completely make the 360 over it. In most of the projects, we'll end up with something like 100 to 200 photos. Don't expect a good result if you take only 5 or 12 pictures, okay? Another very important aspect of this technology is that the content itself or the object you are looking at must have a lot of texture. We cannot extract any signal, any information from a white wall, okay? Also, shiny objects or transparent objects are very difficult to handle because when you move around, the reflection over the body of the object will change. So for the engine, it will be very confusing. So texture object, not shiny, not transparent, will have a good result. And last but not least, these objects that you're looking at or you're taking photos of must be fixed. Okay, so if you're, for example, taking photos of a human body or a face, it must be absolutely fixed. Okay, so once you've got that, it's pretty simple. You have to upload these photos to a photo to 3D service. Here in Autodesk, we have two web services that can use this technology. One is called 123D Cache. Is our consumer version. It takes, it's really for consumers that want to share their result with their community. It's a free service. There is no API. It will have a limited features in terms of number of photos that you can upload on the resolution of those photos. With the Photo on Recap 360 is our professional version of it. It works on the Autodesk secure cloud called Autodesk 360. There is no community aspect to it. It's really your own private cloud. You can upload your photos. Nobody will be looking at that. And also it comes with, if you want to process, it's not for free. You have to spend a few cloud credits per project. The price is exactly 5 cloud credits per project. On 1 cloud credit on Autodesk 360 is $1. So basically, think about $5 per project you're creating in 3D from photos. Also, an interesting aspect, if you are interested, this technology also comes with a web API. So if you want to embed this photo to 3D web service in your own application for your own customers, please let us know. We can discuss that. So the Photo on Recap 360 service, how does it work? Again, you start by taking photos from any type of camera. We also support the GoPro Hero 3 Plus Black Edition, the one that has 12 megapixel sensor. Please do not use any other one. When you use a GoPro, please also use it in a time-lapse mode with still images, not with the video. Okay. Otherwise, it works very well. The advantage of the GoPro is that it has a fisheye lens, something like 127 degrees, so you can really capture a lot of information in each of the photos. So overlapping is made much easier now. So after you have shot these photos or taken these photos, you can upload them to our recap360.autodesk.com, and that will create a 3D model, being a photo texture mesh. Or a photo-based point cloud, the same type of information that you would get from a laser scan. On that, you can use this 3D reality data then in the complete Autodesk portfolio for anything like renovation, visualization, visual assets, game assets, etc. We also added another piece of technology very recently, which is a project Memento. If you end up with very large meshes, and this may happen because you know, when you create a 3D model with very high resolution photos, like something like 20 to 40 million pixels each photo, let's say you have 100 or 200 photos of this kind, you may end up with millions of triangles. So there's no easy way to handle millions of triangles on any software except in Project Memento. So Project Memento will be used to handle very large meshes that you can then clean on heal and we can fill the hole, something like that, and then you make it ready for 3D printing. So if you want to do a photo to print, Project Memento is a nice way to do that. It's available for free on Autodesk Labs for now. So the process then of using a UAV is very simple. You take a camera on a drone or UAV, you create a series of photos all around this object, for example here a gym center. You upload those photos on the cloud, you create a 3D model, and this is the type of result that you would get from this. Let me just pause on this one. Here what you see the 3D model being created here. It's a photo texture mesh. This has been done automatically. You see the 3D icons in space, and for each of the 3D camera in space here, you have got the corresponding photo. I should say the other way around. For each of the photo, we computed the 3D camera in space, okay? So this is a 3D model, and this will be displayed in a web viewer. So on recap360.autodesk.com, it comes with a viewer where you can see this result. This is a resulting 3D model as a mesh, very high density mesh. Look at the quality of the texture mapping. And this is the same information now as a photo-based point cloud. Okay, so instead of a triangle mesh, we have now a point cloud. Very similar information that you would get from a laser scanner. So what do you do with this point cloud once you have computed this information? In this case, for example, we import this point cloud as a RCS file directly in AutoCAD. So this is now the same point cloud in AutoCAD. And in this, you have a lot of tools to handle point clouds in AutoCAD as a whole Autodesk family anyway. And for example, here the user is snapping AutoCAD 3D primitive onto the point cloud in order to simulate like a second floor to this gym center. So anything around conceptual modeling, say again visualization, turning this series of aerial photos into a 3D model is becoming very, very simple. This is another example of, in this case, something a test we did sorry about the noise. This is an octocopter flying a digital SLR, so a more expensive equipment. I'll come back on this a little later. Doing a test here in the AT&T park here in San Francisco. And this is a result we got from this flying camera. And this is a set of something like 200 photos, high resolution, and this is a point cloud as well. So when I zoom in here, you will see that this data is a very highly dense point cloud, in fact. Okay. And the point cloud format for Autodesk is now called RCS, meaning Reality Capture Scan. And this is real RCS files will be recognized by all the Autodesk products, AutoCAD, Revit, Inventor, Navisworks, InfraWorks, 3ds Max, etc. So we see a strong value in being able to fly a camera for various use cases, being again visualization, control, say measurements, and things like that. This is a landscape of UAVs or drones that you will find on the market today. We have tried all of them. So it ranges, you can really buy, I would not advise the toys of course, but you can buy a consumer version of the DJI Phantom 2 or 3D Robotics Iris for less than $1,000. On top of that, of course, you need to add the price or the cost of the GoPro camera. And again, if you want to use a GoPro, please select the GoPro Hero 3 Plus Black Edition with the 12 megapixel sensor. Okay? Most of them come with a gimbal to stabilize the camera. We also have here in-house the 3D Robotics X8. You see it has 8 blades. It can carry a bigger weight. And some of us also have got like octocopters or hexacopters. The more blades and the more power to lift more heavy equipment. So some people now are even flying, say, high-end digital SLR went on also very high-end video equipment. With Super Pro means for us people that have created their own business out of flying very specific equipment. I'll show you an example of that for very specific use cases in the industry, being monitoring construction site or monitoring poles, something like that. So again, if you want to have a first look at what you can do with a UAV and a camera, I would strongly recommend either one of these two, either the DJI Phantom 2 or the 3D Robotics Iris. Let me show you what we can do with the DJI Phantom 2. This video is available on YouTube, in our YouTube channel, so I will switch to YouTube now. So this is a test that we did as well here in San Francisco area, in Marin County. So here I used a GoPro on the DJI Phantom. This is a battery here in the Marine Headlands, north of Golden Gate Bridge. Flying my GoPro here, taking a series of pictures, using a Recap 360 to create a new photo project, creating an RCS file. So I took about 100 photos here. This is a UI you will have on Recap 360. At some point the result, let me pause here. Here what you see in space again are all the camera location for all the photos that I've been taking for this project. Again, trying to fly around the scene in most cases. In this case, I didn't need to have the back of this battery, so I just flew over the front of it, but I also put the camera inside. So here in this case, I didn't fly the drone inside. I just was handling the camera with my hand inside the building. Okay, so this is a mix of flying exterior with a drone, on handling, on having the camera in my hand for the interior. And again, this is the same a single project. So this is a resulting point cloud computed from this set of photos. And you can see by clipping the point cloud that we can see the inside. This is an interesting project. The goal here was to be able to simulate what could be a new building using this existing facility. So we asked an architect to work on Revit, using Revit, to build a restaurant. Okay, so here in Revit is now using the point cloud. Let me take the sound a little down. So I don't know if you're familiar with Revit, but this is our architecture tool. So you can snap Revit primitives onto the point cloud. Here doing some layers, working on several floors. Here's the designer working on several design concepts for this future restaurant. This is one concept. This is another concept. Okay, at some point he's happy with the concept and he can turn that into a more advanced project. So this is a final project. You see it has a few floors in Revit. These are the Revit files. So this is really about making a quick conceptual model using this photo-based point cloud. Also in Revit, what you can do is simulate the exact shadow casting on lighting conditions by geolocating the place, on doing some analysis with the real light. So you can see how the shadows now are being casted on the point cloud as well. Okay. So all this was done in about 2 days of work, about say 1 hour flying, 1 hour processing the photos with a very cheap equipment like a DJI Phantom plus a GoPro on my dog as well. But this one is not for sale. Okay, let me come back to the slide deck. This is another example made by this company called ScaleCatch for their customer called Clayco. ScaleCatch is a San Francisco-based startup, very interesting startup based in San Francisco, developing specific UAV solutions. And what they do is autonomous, sorry, come back. They do autonomous drones to fly over construction sites. So here you see the drone. It comes with a case, and the case will make it fully autonomous. I mean, you don't have to fly it. The flight will be controlled by the a flight path that you have defined first on your iPad. Okay, let me show this again. So you see, the case comes also with new batteries. So after a first flight pass has been done, the UAV will come back automatically to its case, and the battery will be changed automatically as well. So you can imagine that you have the drone flying every day. Nobody is taking care of it. It does its own stuff. And the goal here is really to define what they call a flight path. So this is the existing site, the construction site. And the flight path that they have defined is this one. So the drone will be flying along this dot yellow line, and will be doing that every day in order to monitor the construction site every day and to do some comparisons, measurements on everything you do. You want to monitor on the construction site. Okay. So by capturing this information, you end up with a photo-based point cloud, again inside Recap. This is a point cloud version of it. And this is just another use case. So you have more and more of these companies developing specific UAV solutions, leveraging Autodesk Web API for the photo to 3D reconstruction process. And then you can, if you are interested by any of those companies, please let us know as well. What about accuracy? A quick overview. We did a ground truth test for the accuracy, comparing LiDAR, so laser measurements with total station with measurements got from UAV on the camera. Something I forgot to mention, of course, is when you are in the photogrammetry process, at some point you will need to give a scale to your 3D model. Okay, so either you do this by adding survey points into your photo to 3D process, or you can also add a simple reference distance in order to scale the scene. So we did this test with this equipment, and then the workflow was to import the raw data into AutoCAD Civil 3D from a total station, and then compare that to LiDAR values, and then process the imagery, and then compare the resulting measurements, and evaluate the differences. This was a pretty big project, about 900 feet, and the resulting accuracy we get is really good. So from aerial photos, you would get something like 0.09 inches, so 1 inch accuracy, sorry, 0.09 feet error, so about 1 inch accuracy. On the after point adjustment, you will get something like less than an inch. And but it's about the same error you would get from a LiDAR measurement. So very comparable accuracy in this case, because we have got very good photos to cover the site. And so you can, this is becoming a very trustful way of capturing sites. We did that as well for volume calculation. So in order to compute the volume of some stockpiles, and it's somewhere in between ±3%. Okay, I think this is time to stop and ask for answer questions. These are the few links that you will have where you can find more information about Catch or Recap or Recap 360, or also for Project Memento that I mentioned. It's also available on Labs. Now I'm ready for Q&A.
Great, Dominique. Great presentation.
So we had some questions.
Yes, very interesting, Dominique. So, first question is how to get more dense point clouds. Do we need to use a bigger resolution and more cameras?
Yes, there is a linear correspondence between the resolution and the number of photos and the density of the mesh. So the higher the resolution of the camera, the more pictures you have, the denser the mesh. Definitely.
Okay, great. How easy are these drones to fly. Can we learn them easily?
Yeah, if you start, all these drones now, all these UAVs are controlled by GPS. So, for example, I have I have a DJI Phantom 2. It took me less than, say, 1 hour. Let's say even 30 minutes to learn how to fly it. So there are a lot of videos online. Of course, this is when you fly with the GPS control. Basically, with the GPS control, the drone will be stabilizing itself in space, in 3D space, just waiting for your next command. You can fly it, say, without GPS, but then it's challenging. Then you need to be a real pilot. But again, if you have a GPS controlled drone and they all come with a GPS, it's very easy. Most of the drones also come now with the capability to define flight paths. You don't have even to fly it. Okay, so this will be an automatic flight based on the flight paths that you define either on your iPad or your iPhone.
Okay, we saw this example with a GoPro camera. Can we mount other cameras, DSLRs, to get better models?
Yes, definitely. And again, the better the camera, the better the quality of the model. So you will have a better quality with a higher, more expensive camera like a digital SLR. The point is that if you buy like a DJI Phantom 2, that this is very specific for a GoPro. You cannot mount a digital SLR. Digital SLR is much more, is much heavier. So you will have to buy a more expensive equipment, something like hexacopter or octocopter.
Okay, and I have a silver GoPro model. Are there other lenses supported with official lenses supported by Recap 360?
For the moment, we only support Recap. So there's a GoPro Hero 3 Plus Black Edition. There is a new version coming that will support the silver, but it's still under test. So if you are a little patient, I would say yes, we will be able to support the silver edition as well. But for the moment, you will only support the black one. And I would say I would advise you to have, the better the camera, the better the model. And there is a big difference between a silver camera, a silver GoPro, and a black GoPro. The sensor is not the same, the mounting of the lens is not the same. So again, if you have to select one today, please select the Hero 3 Plus Black Edition. The silver has a 10 megapixel sensor, the black has a 12 megapixel sensor, but also the lens is better.
Okay, I have a lot of questions, but we have time for maybe 2 more. So how are the drones powered? How long is the flight time? Are they charged with lithium battery, rechargeable, etc.?
Yes. So usually you can fly a drone from somewhere from 10 to 30 minutes. So at some point it depends on the weight that you carry, but at least you can, the ones that I have can fly at least 15 minutes with no problem. And you know, with 15 minutes you can do a lot of pictures.
Okay, and maybe one more for the end. Can you elaborate more on making models from inside the building? Is that possible, and how do we do that? Or we need laser scanner, maybe?
Yeah, certainly for anything around engineering work, we recommend using a laser scanner for interiors. In the particular case of the battery that I showed on the video, this is a very specific case because the battery was full of, I know how you call that in English, the tags, on the wall. Sorry? Graffitis on the wall. So it's a very easy case for a GoPro because usually in interiors you have a lot of white walls, you have a lot of reflections on a lot of glasses as well. So we recommend using a laser scanner for interiors. But everything around exterior shapes, building shapes, for conceptual modeling, on the terrain, on evaluation, and things like that, flying a camera can make it, definitely.
Okay, Dominique, great presentation. Thank you very much. There are many more questions, and we'll make sure to answer them after this session. Thank you again for attending. make sure to sign up by going into our blog for our next sessions. We have Chad Studer, a technical expert, and he'll explain laser scans and how to do as-built modeling and renovations from a laser scan into Revit, how to do clash detection in Navisworks, etc. Very useful, and that topic is going to be a little bit longer, 1 hour, so we encourage you all to go there and sign in. Thank you again for coming. We'll share a recording with you of this session. Thank you again. Thank you, Dominic. That was great. See you next week.
Bye-bye.
Thanks.